All right, last panel of the day. Last chance to sit down. Guys, this is the panel that you've been waiting for. We're going to talk about not just what we have right now, but we're going to talk about the future. And not just the future with software, which I usually talk about quite a lot, but actually hardware. So I'm really, really excited about this panel. It's a last-minute addition to the agenda. We just made it happen like yesterday, so I imagine half of the people here don't even know that this is happening. But anyway, we'll do it anyway. I've got on stage here with me a bunch of representatives from great companies, all building amazing hardware products, from silicon all the way up to electronics, up to software. And we're going to learn a bit about what they're working on and maybe even why. So for the introduction round, let's just go through, maybe everyone just say quickly who you are, what you're working on, and yeah.
Start with me. Okay. My name is Scott. I'm the instigator of what has grown to be a much bigger project, but I'm the instigator of the BitAxe project. It's a small open source ASIC Bitcoin miner. So yeah, that's what it is.
My name is Sandeep Gupta. I'm from ZetaGig. We are a startup company, semiconductor high performance computing. We are building Bitcoin mining chips, mining manufacturers.
Good afternoon. My name is Thomas. I work with Brains as a head of product development. We do a lot of software products for Bitcoin miners, starting from mining pool, firmware, farm management solutions. But here we are to talk about the hardware. So we started to do recently quite a few hardware products, from control boards to PSUs to a small miner that you can check at our booth with 1 terahash that you can use as a scratch card.
Hi, I'm Henry Kwan with Foundry Digital. I'm VP of mining equipment, looking at how we can improve the hardware ecosystem. So from top to bottom, was for our pool, and I'm looking at ways that we can help you make mining more efficient.
Hello, I'm Earl Mai, founder CTO of Epic Blockchain. We focus on firmware, software control boards, hardware, rigs, everything related in the Bitcoin mining space.
It's really great to have you all on stage. So there's a lot of hardware being built, right? We all know mining is already happening for 10 years, right? I mean, who needs new hardware? We've already got existing hardware. It's working great. So my question to you is, with the products that you're building, why are you building them? What got you into the idea of developing what you're currently into? How close are you to achieving that goal? And what will we see in the next year?
The BitAxe project started as just an idea, like I want to make a miner. My background's in electronics and electronics design, and I thought Bitcoin's cool, Bitcoin mining's cool, maybe I can make one of these. I come from a background of open source, firmware, hardware, things like that, and so at the time I just assumed that I would be able to go and get open source designs to build something like this, and quickly realized that while Bitcoin mining originally started off as an open source activity, which anyone could get involved in, it had closed down. It was no longer open source. And so it was like, all right, I guess I'm going down a much bigger rabbit hole than I originally intended, and had to start from the beginning, reverse engineer Bitmain ASICs, like several of the panelists here have done. But just decided to release everything that I had done open source, and that attracted several other developers, and the project took off, and kind of came to revelation that Bitcoin itself is fundamentally open source. The reason why we're all here is because Satoshi had open sourced Bitcoin in the beginning, and it allowed all of us to get into it and start screwing with it without having to ask anyone for permission to do so. And I just want to bring that ethos back to Bitcoin mining. It started off like that, and I want it to be something that anyone can get involved in the design, in the development, and improving to Bitcoin and Bitcoin mining?
So I got involved into Bitcoin mining space a couple of years ago. What I noticed, my background is all in semiconductors. I build ASICs, hardware, and I'm on the manufacturing side and the design side. So the reasons I got involved into this project was I saw that Bitcoin is all about decentralization, decentralized finance. I saw the mining manufacturing space being concentrated into the hands of a few manufacturers. On my fingers, I could count them. So I saw that there's a big opportunity here as a mining manufacturer as well as an ASIC guy to build a system, an ASIC chip for Bitcoin mining, which will help the decentralization. So we are amongst the very few, only amongst a couple of semiconductor companies who would be building mining ASICs in the United States. And that was one of the goals behind forming ZetaGig. And that's what we are doing after having announced our first mining ASIC, Z1 ASIC.
So Bitcoin mining is the mission of Brains. So we do everything to help Bitcoin miners to mine better, faster. We spent the past more than 10 years producing high-quality software ranging from a mining pool, Stratum protocols, mining firmware. But we do see opportunity in hardware as well, not just because of that we think that we can do products that are better, more usable, have better features, but also as a counterbalance to the centralization that my colleague talked about that we see, and also as a kind of a de-risking mechanism that would allow us to eventually use and apply our firmware solution on our hardware that would not be vendor locked, as is the current state of majority of the market.
So Foundry Digital has been founded based on the fact of trying to build a decentralized system. There's two main premises to what we're doing in hardware. The first is to help build open platform and open standards so you can innovate. Today the hardware manufacturers control their destiny, basically dictate your destiny. You don't know what you're going to do in the future in terms of power. You don't know what the platform looks like. The form factor is all different. So it's very hard for you to plan going into the future. So at Foundry, what we'd like to do is work with the industry to define new standards to say, here's what data centers will look like, here's the form factors, here's the components that you can put in to make things more efficient. Right? So that's our first goal. The second goal then for us is to that's the altruistic vision. Our selfish mission is, of course, to build products to help you improve the quality of your life. So what are these key quality components? We'll supply them, they work, right, and they integrate easily.
So we're all here for a mining conference, and we all buy equipment from several of the manufacturers. We buy from BitAxe as well. When it comes down to it, at Epic, what if we gave you the choice to build whatever you wanted? Who is to choose that this shoebox that we all buy is the right thing for the data center, the right thing for your use case? At Epic, we work from a software, hardware level to create miners that integrate into the immersion systems. We do it on air, we do it everywhere. So really, we represent an optionality for people in the mining space. We find partners who make chips, like ZetaGig up here. Chain Reaction, I know, is down there, over there somewhere in the Sprite lights, but we build systems for people. And you tell us what you want, what software you want, and it'll help you get that vision out there.
Right. And Earl and I come from the PC industry, so we're used to this open innovation, open standards. There we can build better platforms by working together.
That's super, super fascinating. And actually, that's exactly what I wanted to ask about next also. Because, what I've been seeing over the years of mining hardware evolving, it's always been the manufacturers producing fully finished mining machines, usually the shoe boxes, right? Then you buy your PDUs, you buy your network, you build your data center, and you kind of plug it all together. Now, of course, each of those components is interchangeable, but there hasn't been too much real innovation in the design of the machines and the customization and so on. But now in the recent years, we're hearing a lot about immersion, right? Many people here in the conference have got really, really interesting immersion setups and all kinds of interesting ideas floating around. And I'm wondering, are we going from the hardware design perspective, are we going more in the direction that these traditional different units that you buy, will they be mixed and matched differently? Maybe will chips be sold separately from the mining boxes, for example? Might the immersion or data center design guys integrate in a more closer way with the system designers? I'd really like to get your guys' perspective. Let's start from the other side, maybe. Earl, you've already been talking about it.
So what we're seeing is people demanding something different than what you get. Typical today, an immersion system that you get from the large manufacturers is an air system without the fans. Yes, they have a beefier power supply for overclocking, but that's not an efficient way to mine. From a density standpoint, a lot of people are trying to increase density. From a control standpoint, why does every miner need an Ethernet controller? One Ethernet controller can do a whole immersion tank or a whole rack. So we're seeing people come to us now asking us the question of, if we could build it this way, can you do it? And having the optionality of using different chip manufacturers gives that flexibility.
So I would agree with Earl, and I go one step further, right? We need to standardize the form factors, you need to standardize power connectors so that you've got this, and the software API, so that we've got this interoperability where you can plug and play, right? You can take one system from another vendor, plug it into your unit, have another one sitting next to it. So they all work together.
Well, I would add that one of the major blockers for the innovation in the past years for me was the unavailability of chips that you can source on the market. I see that is slowly changing. I see a big demand from different projects across the industry to do cool things, to do small miners, heat miners. But as long as you can't source chips reliably, that is something that really blocks the innovation. And I think it set us back like a couple of years just because of the vertical integration that we currently see on the market, where 90% is controlled by basically two entities.
I couldn't agree more. I come from a background where we used to be just semiconductor suppliers supplying the chips to the system integrators. I noticed in the Bitcoin market that the system integration is done by the semiconductor supplier, and it doesn't have to be. I agree with Henry and Earl that a semiconductor supplier should be open to supply just the chips to our customers, and they can do the job of integration. It requires close coordination prior to release of the product, maybe several months in advance. That's how I'm used to in my semiconductor world, that we can supply chips, and absolutely a system integrator should be able to build it, the full system around it. It requires closer coordination, sharing of specs, maybe sharing of some key IP, but it's possible. The reason it hasn't happened here, I believe, is because the amount of silicon content on a miner with hundreds of chips talking to each other from a semiconductor manufacturer, I think that is the reason, instead of any other secret reason why this has all fallen into the hands of the semiconductor designer, like designs the chips, connects 300 of them together on a mining system. So it's a natural flow. Could it be decentralized? Absolutely. Will it be good for decentralization? Absolutely. That's what I would say.
Yes, absolutely, 100%. We need to be able to buy, the individual components, especially the chips, the silicon individually. And I think there's a really important reason for that going forward. If we look at the way that, I don't know, maybe 90% of the miners look now, they essentially look like an S19. I mean, they have different stuff inside, but they look like an S19. And that form factor, that design is designed for use in a grid-connected data center, and basically nothing else. Like, it is purpose-built just for that, because that's what 90% of the miners want to do with it. But I think going forward, we're going to have, we've heard about all the delightful new applications for mining: heat reuse, stranded energy, solar, like going after cheaper and cheaper energy. And I think the fact of the matter is those machines are different. They look different, they have different power sources, they have different power consumption, they have maybe a variety of customizable firmware. And we need a bigger variety of system integrators to build those things for these industries, to take advantage of it and essentially keep mining profitable.
Now, I think I'm asking two easy questions because everyone's just kind of agreeing, right? I mean, the interesting thing is everyone sitting here on stage is having these great ideas about the decentralization of the hardware space, about how things could be done better. But if no one's offended of me saying so, no one here is one of the very large hardware manufacturers in the space today. So I do think that we need some kind of driving force to push forward on these ideals and to decentralize the market a bit better there. So my main question would be then, and by the way, unfortunately, none of the larger manufacturers could come on stage today because I think their perspective would be also really interesting, right? But what do we need to make this vision kind of happen a bit more, to decentralize the hardware space, to have more players involved, to allow for more custom designs, and maybe also to decentralize a little bit out of China a bit more? So what's the biggest hurdles in the way that we're currently looking at? What are the big steps that might be necessary, and who needs to take them in order to make steps here in the right direction? Maybe Scott, we'll start with you again.
Okay. I got a pretty good idea. I think it takes a lot of parallels from the development of the internet, the development of the web, but we need to open source this stuff. We open source this stuff, and that in essence makes it completely permissionless for someone to take the chips, and they can get a data sheet, and they can develop their idea without having to ask anyone, without having to sign a multi-million-dollar purchase agreement, and they can try out their idea. And if a bunch of different people, a bunch of different entities do that in their garages, some of them will fail and they won't buy any chips, but a lot of them will come out with these amazing ideas. And it's going to be this exponential growth in the development of the Bitcoin mining ecosystem. And I think there's a lot of parallels to that in the development of the internet and in the web. One of my favorite sort of stories, I guess, is that Microsoft used to make a web server, or make a web server software. Like, it was proprietary, you had to buy it, you had to get a license. But I don't know, like perhaps 0% of the internet, of the websites now are hosted on Microsoft's proprietary web server, right? Linux came along, Apache, Nginx, all the other open source web servers came forward that allowed people to just grab it and start building with it and produce profitable big companies that are completely changing the industry. So I think that open sourcing it, or at least making it more accessible to people who want to screw around, is just absolutely opens the floodgates to development.
So the devil is in the detail, Philip. I think you're having a lot of agreement because we did not go into the detail. So let me touch upon the detail a little bit on this. So about mining manufacturers, about 80 to 90% of the content, if you see inside the miner for the silicon, belongs to one company. So it's only a natural progression that a Bitcoin mining ASIC provider, who the 90% of the silicon content belongs to, would also manufacture the miner. That's the basic reason. Now, if you do want to decentralize it, then there's a couple of paths. One is the mining manufacturer, if that's different than the ASIC vendor, then the mining manufacturer can work with the one ASIC vendor and design around his chips a manufacturing board or a manufacturing miner. And that's one way. The other way is the harder way, and that will be true decentralization, if that can ever be achieved. The true decentralization can be achieved if there were to be a standard around the chip. A standard around the chip would mean a constant voltage, a voltage which everyone shall operate at, or a interface which is a spec for the UART or any other serial interface around the chip, which everyone shall operate at. So that would be the standardization of a chip, where a mining manufacturer, a third party, could come in and say, I will integrate an Auradine chip or else a Bitmain chip with a ZetaGig chip and yet be able to operate it. That's the true sense of decentralization. Now, that's ideal, very difficult to achieve. So now if we say that it's difficult to achieve and we don't have those standardization, and you're working with one mining ASIC vendor, then 80 to 90% content belongs. So that's why the market has accepted this centralization of all systems efforts from the mining ASIC vendors. So to truly change it, that would be the change which would be needed. Otherwise, the mining manufacturers would be working once again at the hands of one mining ASIC vendor and not doing the decentralization in the true sense. That would be my quick opinion, and that was on-the-fly answer. I did not prepare this, so I could be wrong on the future thinking. Thank you.
So, Philip, you asked for what the hurdles actually are, and I think one of the huge hurdles is actually the financial one. When you have vertically organized huge vendors, they were able to squeeze best pricing, best supply chains. So fighting against that as a smaller company is very challenging, because you will not be able to compete on the pricing, perhaps. And at the same time, let's be honest, they have like a 10 years R&D, they are ahead in most cases, and it's a moving goalpost. So you have to always iterate and find the next best ASIC, improve all the details, and that gets very expensive. So having a better chip and cheaper chip at the same time, I think is extremely unlikely. Maybe someone will manage, but I don't think it is easy. So what we believe is there has to be some willingness to form some strategic partnerships, whether it is between the ASIC manufacturers and system manufacturers, or even the chip manufacturers and mining companies, someone who is willing to sacrifice short-term some profits in order to have a long prospect of self-sovereignty, having the capability to do their own stuff without being reliable on the big two companies.
Open source of ASICs is a tough thing, right? You're going to need, you need proprietary design tools, you need $50 million or more, Earl can probably correct me on the number, to do a 3-nanometer chip. So I doubt if open source is going to happen from that standpoint. Open source can happen from a platform. You know, we can standardize on the form factor. We can standardize APIs to address this stuff. What do your power supply interfaces look like? So you can part the industry that way. What's going to change the market is the fact that we now have a lot of competitors designing ASIC. So Zetagig is designing ASIC. I know Earl's very capable of designing ASIC. He was on Radeon GPU. So, you know, there's a lot of that competition is going to drive prices down. And what we see is this $5 billion of TAM in the market going to probably condense down to $3 billion, because a lot of that money is profits. And fundamentally, if we can innovate together, then we're going to squeeze those profits out, and what you as the miners then is going to be more profitable, right? You can put in those power supplies that are higher efficiencies and adapt these things to your environment. So collectively as an industry, if we learn to work together like the PC industry did in terms of co-opetition, defining standards, and building, marching forward together, then we basically fight the evil forces that are controlling the industry, whoever those might be.
So open sourcing the chip's never going to work. Foundries are never going to allow that to happen. I think 3 out of the 5 of us here, or maybe more, agree that open source is a method that we need to look into further. I know some of my engineers spend more time with Scott than I'd like to have them, but we try to contribute in a way, and as Henry said, we collaborate. But I think the industry is ripe for a change. There are companies that are making ASICs out there, and I'm aware of at least one that is pushing for open ASICs in the sense that they will just sell chips. And I think that's something that Scott would like, for the fact that you're buying, I think you told me, old S19 chips that kind of work and kind of blow up sometimes. But I think a year from now, if we're ever back on this panel, if you guys let us come back, we'll see where we are, because we're all trying.
And the speed of technology is changing, so maybe Earl can address this one, is we're seeing Moore's Law flatten out, right? So the rate of change in ASICs is a lot smaller than it was before. We went from 200, you know, basically we're down 10x now in terms of efficiency, going from 200% improvement now just to 20% improvement in the latest generation.
Here is one case of disagreement there. Moore's Law is not flattening out.
The open source ASICs comment, you know, a lot of people refer to the whole system as an ASIC, right? I think we're talking about ASIC as the machine. I agree. An open source, a truly open source ASIC is the chip is probably impossible due to the cost and the IP associated with that. But we don't need to let that stop sort of the open sourcing of the system, of the firmware, and maybe even an open standard for interfacing with these chips. I think that's what's incredibly powerful to drive development, is having these open standards and these abilities to get in and design systems. And it just makes it a lot easier if you have at least a data sheet for the chip, and you can just go and buy those from the variety of sellers.
I would love to be in that market where the onus of system development is shared with my customer, and we are supplying chips and working together with our customer, and who integrates, or we also in parallel can build our own miner. On the Moore's Law comment, if I have disagreed with my partner there, I would like to clarify. Every time I thought in the last 30 years of semiconductor that the Moore's Law would flatten out, some foundry proved me wrong. there was around 28 nanometer days, I felt that it's going to flatten out. The gate oxide thickness is reducing so as to pack a few atoms and electrons. And this is the end of semiconductors. And then came out FinFETs. And FinFETs came in and gave me once again the Moore's law application. Now, once again, I saw the same application around 3 nanometer. And now I am seeing advancements on FinFET technology, which is the gate wraparound technologies, which the process foundries are coming up with. So I don't see a flattening out. This improvement is going to continue for a very long term for the survival of semiconductor industry, foundries, and technology in the future.
Do you want to go first?
Yeah. I wonder though, like, has all the like easy low-hanging fruit been picked as far as efficiency improvements and sort of, bringing these efficiencies over to Bitcoin mining ASICs? Like,
Sorry, could you say that again, please?
I'm just wondering, like, are we going to see as big stepwise improvements in efficiency going forward?
I have been seeing pretty constant improvements in efficiency. Look at, without naming any of my competitors, other stuff, with all due respect to them, I've been seeing a factor of 0.7 from one big generation node. Now, I'm not talking about subvariants. If you look at a foundry called T, and I wouldn't want to spell out the remainder of the letters, a foundry called T has had technology called 7 nanometer, and a competitor called B had a chip inside or a system inside it with 29.5 joules per terahash, which when they moved from 7 down to 5, went down from 29.5 to 21.5, and when they moved down from 5 to 3, they came down from 21.5 to 13.5 to 15. Now that's a pretty constant scale of improvement. I didn't see any bound, and this will continue happening as we go down from 3 down to 2, 2 down to 1.5 or 1.4 or 14 angstrom technologies. I don't see that limit right now. 0.7x, 0.65 to 0.7x improvement in efficiency for every one full generation of technology advancement in semiconductors, which happens every once or in 2-3 years. And this rate is almost like remaining constant. Once in every 3 years, I see one node coming up.
So scaling the node is one thing. The foundries, TSMC, they do a great job, but that's not innovation. We're relying on their innovation. What I predict happening in this industry from an ASIC level is we're all converging. Yes, someone like you can come up with an ASIC that is sub 10 joules per terahash, but what's wrong with my chip at 10 joules? There's so much more wastage in this ecosystem going up the stack from a system infrastructure point of view. No one seems to look at Bitmain's new machine and take a look at their fan specs. They're 12 volt, 140 mil, 5 amp fans. They had to go up in fan size just to keep these things cool now, keep temperature stable. There's so many other things to fight over to save power, get efficiency up the stack than focusing on just the chip. So I believe in the future, chips will be abundant, and you will have different chips from different manufacturers, and they have pros and cons. Some good all the way up to 45 degrees C, and some can't run. But if you're in the north, you will grab that chip. That's for you. And let the people choose what they want, right?
Yep. And it boils down to the bill of materials, right? So we can put 3 nanometer in, but it's going to cost more than a machine with 5 nanometer. And it's really about how much can you get, how much hash rate and efficiency can you get for your dollar. So at the end of the day, that's what open innovation allows, that you can make the choice on how to optimize your system and what to put in.
Well, I will add that there are use cases even for different efficiencies. With our firmware, we still see 50,000 S9s are running out there at 90 joules per terahash. And there is someone out there who has a use case for it. So we can innovate not necessarily at being the best on the angstrom level, but I would say that even a new chip at 7 nanometer, 9 nanometer can still find the customers because it will be very cheap. And it can be used for generating heat, not for necessarily generating hash rate. And that is the innovation that we can do together here.
So one more disagreement, sorry, Henry. The 3 nanometer, you said that will be more expensive than 5 nanometer. That's not true. The 3 nanometer will necessarily be cheaper than 5 nanometer. And the reason is very simple. The 3 nanometer, you may be talking about the wafer cost of a semiconductor foundry. But the way we are supposed to do the job when we build silicon is we are supposed to absorb that wafer cost and build a silicon which takes into account the linear growth in the wafer prices as we move technology, and have a square law advantage in our silicon so that the overall cost per terahash goes down as we go down from 5 nanometer to 3 nanometer. Otherwise, the semiconductor business from any major foundries would not exist. And so I'm very much of the opinion that if you have the latest technology, yes, indeed, you would see an advantage in both the cost. As far as the other thing which Earl mentioned, that's a very fair point. That Earl has a very fair point that you can continue to have advancements in efficiency and cost, but what about the ability to cool it? So now that you got to more and more power per millimeter square, your efficiency improved, but the power per millimeter square of your silicon has gone up because you're burning more power, because you're more efficient in the silicon, then in that case, you have to take care of the cooling techniques to scale with that. So I'm totally in agreement with Earl on that one, that those kind of techniques have to scale.
Very, very interesting discussion. Everyone knows that everyone's waiting for these panels to turn into a huge fight. I think we might just stop the panel here before that happens, just to make sure, but we can continue backstage, all right? We've got curtains. Now, guys, I really appreciate you guys coming on and discussing these things that I think are not discussed so much in the usual, in the marketing material of when you're walking through the conference here. You don't hear about this on the usual YouTube video. These kind of discussions, I think, only happen when lots of technical-minded people meet all together at the same space, all in the same mindset, and trying to drive the industry forward. So thank you very much. And yeah, inspiring stuff.